Okay, looking at the Unit 11 test review, let's take a look at number 1. We have the measure of angle B whose vertex lies on the circle, and remember, if its vertex lies on the circle, it is equal to half of the intercepted arc. So 34 equals 1/2 the arc of RD, which we'll just call it X. Okay, multiply both sides of the equation by 2, and we end up with 68 equals X, because when we multiply by 2, it cancels the fraction out. So our answer here is D. Number 2. Here we have a circle that's perpendicular, or diameter that's perpendicular to BC. Therefore, if it's perpendicular, we have our segments that are congruent. It says that AE is equal to 4, and it's incorrectly written as PQ. It should be PC equals 7. So our radius is 7. We're trying to find out segment CE. Okay, now I could use the Pythagorean theorem here because I know one side of that right triangle, which here I'll draw it in blue. I know the hypotenuse to be 7, and we're looking for X, but I don't know what EP is. Actually, if you'll notice, if the radius is 7 and this segment here is 4, this segment has to be 3. So what we'll do now is just solve for X using Pythagorean theorem. 3 squared plus X squared equals 7 squared. And we end up with X squared equals 40. We take the square root of both sides, and that ends up equaling square root of 40 simplified is 2 radical 10. Alright, number 3 here. A circle for a game is divided into 3 regions. RP is the diameter. What's the area of the shaded sector? If RP is 8, if the diameter is 8, that means the radius is 4. So what we have to do, we're finding the area of the shaded sector. We find the area of the whole entire circle, which the formula is pi r squared, which if the radius is 4, we square 4, which gives us 16 pi. That's the area of the entire circle. Now remember, we don't do that. We multiply it times the central angle of the shaded area, this angle here, divided by 360. Well, when we do that, notice this line means that this angle is 180. If that angle is 180, we need to take 180 and subtract 45 from it, which leaves us with 135. So that's my central angle, 135. When I multiply 16 pi times 135 over 360, you should get 6 pi, which is B. Okay, number 4. Very similar problem. In fact, we're going to do that right off the bat. We're going to find the area of the circle whose radius is 12. So we're pi r squared again, which 12, that's pi times 12 squared, which is 144 pi. And we're going to multiply it by central angle 40 over 360. So that will give us the area of this entire sector. And when we do that, 144 pi times 40 over 360, we get 16 pi. Now we're going to find the area of this small sector and subtract it from the large sector to find the area of the shaded. So we see that if this is 9 and the whole thing was 12, well, this one has to have a radius of 3. So we're going to go pi r squared with a radius of 3, so 3 squared equals, that's going to be 9 pi. Now we're still going to multiply it by the same central angle, which is 40 over 360. When I do that, I end up getting 1 pi, or just pi. So 16 pi is the whole thing. The unshaded area is pi, so we're going to subtract 1 pi, or just pi. It's going to leave us with 15 pi, which is the area of the shaded section. Okay, number 5. In circle U, we have TS equaling 15, which if this radius is perpendicular to it, it means that they're both congruent, so this is also 15. And UQ and US are also congruent to this chord, which would mean this is P, this is R. That would mean that the two chords are congruent. So if each segment here is 15, the whole segment is 30, which means that PR is also 30. And my answer is B. Okay, looking at this, we have a circle with two vertical angles. The vertical angles are going to be congruent to each other. You can't read it here, but they are 3x plus 35, and we can set them equal to each other to find the value of each angle. Equals 4x plus 15. Solve for x. When we do that, we get x equals 20. Now we plug it back in. So 3 times 20 plus 35 is 60 plus 35, which is 95. That means this angle is 95. That means this angle is 95. This is 180 degrees, so 180 minus 95 equals 85, which means this angle is 85, and this angle is also 85. So when we go back through there to find the answer for the next 4 questions, we can just say that PRS is this angle, it's 95. And then QRT is this angle, it's also 95. And then PRQ is this angle, that's 85. And the other angle, which is this angle, it's also 85. All right. Okay, moving on to the next one. Here we have a tangent line and a secant line. A tangent and a secant. And we're looking for the value of x. You'll recall that when they intersect outside and one is tangent, we square the tangent segment and set it equal to the product of the exterior segment 4 times the entire segment, which in this case would be 4 plus 5, which is 9. So x squared equals 36. When we square root both sides, we end up getting 6. Okay, so here we have, this is actually a good question. Well, actually, we're just turning this into an equation given the center. We don't have the radius, which is why it says which equation could represent it. So we do know that we would have x minus, remember the formula is x minus h squared plus y minus k squared equals the radius squared. The h is the x coordinate of your center, the y, or the k is the y coordinate of your center. So what we're going to have end up with is x, it's minus 4, but we're subtracting it, so it's going to be the opposite sign. X plus 4 squared plus y minus 1 squared equals whatever the radius squared. In this case, they just plugged in 41, so that's fine. The 41 is random. They didn't get that from anything else. And your answer in this case would have to be C. It's the only one that has x plus 4, y minus 1. Number 12, find the exact circumference. Well, to find the circumference, we need the radius. Notice this is the diameter. If we could find out what that is, it would be half of that. Now we end up with a right triangle. This is 12. They're congruent. That makes this 12. We could use the Pythagorean theorem and say 12 squared plus 12 squared equals, we'll call this x squared, the diameter. Or we could know that isosceles right triangles are 45, 45, 90 triangles. And to go from the leg to the hypotenuse, we multiply by radical 2. So x, or the diameter, is 12 times radical 2, 12 radical 2. Well, the radius would be half of that, which would be 6 radical 2. Now it finds we're finding the circumference, which the formula for that is 2 pi r. So 2 times pi. I'm sorry, I forgot to put. It's not just 6 pi. It's 6 radical 2 times pi. So 2 pi times 6 radical 2, not pi. We actually end up multiplying 2 times 6, which is 12 radical 2 pi. Goodness gracious. It should be a pi symbol. Which the only one that looks like that, where they have it with the radical after the pi, which is the same thing because you're multiplying all these numbers together. But our answer there is A. Okay, number 13, what is the measure of PR? PR is this arc right here. We can, if we know this angle, it is an inscribed angle, which means it's half of that arc. So we can find that missing angle because 60 plus 50 is 110. And all the angles measures have to add up to 180, which means this angle is 70. Now, if this angle is half of the arc, that 70 is equal to half of the arc. Multiply both sides by 2, and x equals 140. Okay, here we have an inscribed angle. Let me blow this up a little bit. And it says that AF is 3, which you recall, if they're all tangent, it's an inscribed circle. These segments are all congruent, so that's also 3. It also says that AB is 11, so the whole thing is 11. If we subtract 3 from that, we're left with 8 here, which would leave us with 8 here as well. Doesn't tell us anything else, but it does ask us for the measure of BD. BD is this segment right here, which we said was 8. And that's my answer. Okay, here it says, and I'll just leave it blown up like this, it says that TA is 10, it says CD is 12, AB is x plus 2, find AB, oh, I'm sorry, TC is 8. So these are two secants going through here, and remember, they intersect in the exterior. So 8, the exterior section, times the whole segment, which 8 plus 12 is 20, is going to be equal to the other exterior, 10, times the entire thing. So if we take 10 plus x plus 2, we end up with x plus 12 simplified, right? So we'll just do that. So 160 is equal to 10x plus 120. Subtract 120, and 40 equals 10x. Divide by 10, and x equals 4. Now be careful, because they're wanting the measure of AB. AB was not x, it was x plus 2. So we have to plug in 4 plus 2, which is 6. That is our answer. Okay, here we go. Looking at this one, what's the measure of ADC? Well, ADC is an inscribed angle, which it is equal to, it's the unknown, it's equal to 1/2 the intercepted arc, which is 46. So 1/2 times 46 is 23, and that's our angle measure, A. Okay, so here we have a drawing of a tangent and a secant. Use the values shown. What's the measure of D? Or of CD? That's our unknown. Remember, we take the tangent and square it. So 8 squared is equal to the exterior segment, 4, times the entire segment, which would be 4 plus x. 64 equals 16 plus 4x. Subtract 16, you end up with 48 equals 4x. Divide both sides by 4, and x equals 12, which is what you're looking for. CD, we labeled it x, so it works. Okay, word problem here. An architect's using a diagram to design a curved balcony. She drew a circle with a radius of 40 feet and a central angle of 70. So here we have an angle of 70 degrees. The radius is 40 feet. We need to find out how much railing there is. So really, we're just looking for arc length here. This is length, not area of this sector, so we're going to use, if we can find the circumference of the entire circle, which would be 2 pi r is the formula, which in this case would be 2 pi times the radius is 40. 2 times 40 is 80, so the circumference of the entire circle is 80 pi. Remember, we multiply that by the central angle, which was 70 over 360. When I multiply that, it will give me the length of railing that I will need, which in this case ends up being 49 feet. Okay, another word problem with a similar type of process, except this time we're looking for how much glass is needed for the window. We're looking for the area of this half circle, basically. Its diameter is 8, so the radius is half of that, which is 4. We're talking area, so we're going to use the pi r squared formula, which is the area of a circle. Pi r, radius is 4 squared. So we end up with 16 pi. Now this isn't the whole circle. How much of the circle is this? It's actually half, so we can just take half of that and get 8 pi as our answer. That's the area of that circle. And then we have a pizza question. It has a diameter. Let's just draw a quick little picture for that. It's a pizza, has a diameter of 16 inches. What's the area of one slice if it's divided up into 6 slices? So basically it has a radius of 8. It says the area, so we'll be using the pi r squared formula. So let's find the area of the whole circle. The radius is 8. So pi times 8 squared is 64 pi. That's the area of the whole pizza. Well, how many different pieces are there here? There's 6, so couldn't we just divide that area by 6? And when you do that, you end up with this as your closest answer. Alright, the next problem. We have a circle with a center. It says which point is on the circle. Let me just give you a hint. Well, the hint is write the equation of the circle first, so let's do that. That would be x. We have minus 2, so inside of the parentheses it will be plus 2 squared plus y. We have positive 3, so we're going to put y minus 3. Then we're going to take the radius 4 and square it, which would mean it's 16. So that's the equation. What I have to do now is I can plug each of these numbers into that equation, and the only one that works will be the one that is on the circle. So when I plug all these in, for instance, and actually I'll just tell you right off the bat, the correct answer is B here, because when we plug in negative 2, let's see this, negative 2 plus 2 squared, well then it ends up being 0 squared, plus the y is negative 1 minus 3 squared. Well, that ends up being negative 4 squared. Well, when I square -4, does that equal 16? Yes, it does. It's the only one that makes both sides of the equation equal. That's how you'll make sure that it is on the circle. The other points are not on the circle. Okay, we have a wagon wheel here, 12 congruent triangles. What's the degree of WG? Look at WG here. It is that angle right there. So what I need to do is I need to figure out what each central angle is. Well, one full circle would be 360 degrees, correct? If I divide that by 12 different sectors, we end up with 12 goes into 360 30 times. That means each small triangle is 30 degrees. Well, if I look at WG, it's got 1, 2, 3, 4 triangles, so 4 times 30 is 120, so WG has an angle measure of 120 degrees. Okay, 23. AB is tangent. AB is 15. And the radius of the circle is 8. That means CB is 8. If it's tangent, it's a right angle. Find AC. Well, that's this hypotenuse to this right triangle. So we'll use the Pythagorean theorem. 15 squared plus 8 squared equals x squared. 225 plus 64. When we add that up, we get 289 equals x squared. Well, when we square root both sides, we find that x equals 17. C. Okay, TW is the diameter of circle X. That means it splits it into two half circles. And these two lines are parallel. Therefore, this arc should be the same as this, meaning it's also 25. We are to find the degree of UV, that arc. Well, if we have 25 plus 25, sorry, it's going to be 50. And if the whole entire half circle is 180, we take 180, subtract 50, and that will give us the arc that's left, which in this case is B. Okay, and now we have chords A, B, and C, D. They intersect. Find the measure of RB, X. Okay, they intersect, so you'll remember this is where we take the product of 2 and X, which is 2X, then the product of 3 and 5, which is 15. 2X equals 15. X equals 7.5. Okay, LO is the diameter of circle P. So here we have the diameter. What is the measure of LMO? LMO. This angle, it's an inscribed angle. You'll recall it is equal to half of the arc that it intercepts, which if this is a half circle, this is 180. So my angle measure, what I don't know, is equal to 1/2 the arc, which is 180. When I do that, I end up with 90. Or you could have just known that an inscribed angle whose endpoints are on the diameter, it's a right angle. Okay, so here we're going to find the center and the radius and graph it. Which let's find the center first. Remember, if it's x minus 2, the 2 is positive. Minus 3, it's positive 3. The radius squared is equal to 4, so the radius is actually 2. That's how we get that. So let's plot the center on our graph. 2 over 1, 2, up 3. That's the center right there. Now the radius is 2, so I count 2 up, 2 over, 2 down, and 2 over. Connect those dots for the radius, and you should get a circle that looks something like that. Okay, find the area of the shaded region. First, let's find the area of the square. If it's a square, then it's 12 by 12. 12 times 12 is 144. The area of the circle, if it's 12 across, then half of 12 is going to mean it has a radius of 6. So that's going to be pi r squared, or pi times the radius is 6 squared, which is 36 pi. Now the shaded area is going to be the area of the square, 144, minus the area of the circle, which is unshaded, 36 pi. It asks for it in terms of pi. If we put that in our calculator, we'd end up with a decimal and have to round it, so we'll just leave it like that. Okay, 29. In circle O below QP is tangent at point Q. So ON is 8, NP is 2, find QP. So what we end up having is X, that's our unknown. Our tangent segment, we're going to square it and set it equal to our exterior segment, 2, times the whole segment, which in this case is 10. So we have x squared equals 20. Take the square root of both sides, and square root of 20 simplifies to 2 radical 5, which is the length of QP. Number 30, we're going to have to go back to some SOHCAHTOA. We have a right triangle with a segment of 12 here, x here, and an angle measure of 26. We know the angle measure, we're looking for the hypotenuse, and we know the adjacent side. So that is cosine. So the cosine of 26 degrees equals the ratio of adjacent over hypotenuse. So that would be my equation. If you recall, if we're dividing by x, we're going to divide 12 by cosine of 26. When we plug that in our calculator, round to the nearest tenth, we should get 13.4 as our x. Alright, and here we have, with no pictures, but we have basically it's a pentagon. It's a bad attempt at drawing a regular pentagon. Measure of each interior angle. Well, how many interior angles does it have? It has 5, and remember they have to all add up to 360. So, I'm sorry, and that's not what we're looking for. We're looking for the interior angles, not that part of the angles. We're looking for these angles, which they're all congruent. The measure of each, well, remember, the measure of the sum, and we'll skip down to this section, is where we take the number of sides of our polygon minus 2 times 180. So in this case, 5 minus 2 times 180, which is 3 times 180, is 540. Now, each angle is going to be congruent, so we take 540 and we divide it by the number of sides, 5, which we end up with 108. Remember, that would be n minus 2 times 180 divided by n. The measure of each exterior angle, that's, well, the sum of the exterior angles. Remember, all the exterior angles add up to a sum of 360 degrees. To find each individual one, we take 360 divided by n, which in this case is 5. We get 72. And the last question in the review says that we have a right triangle, again, some SOHCAHTOA here. I have 8, I have 15, and I have an unknown angle measure which I'm looking for. This is the hypotenuse in relationship to my angle. This is opposite. So I'm looking for the sine ratio, OH. So the sine of x is equal to the ratio opposite over hypotenuse. Now remember, this is where you put in your calculator second, and you get this button, second sine, and you put the ratio in, 8 over 15. Round it to the nearest degree, so we're rounding it to the nearest whole number, which should give you 32. All right, hopefully that helps you, and you're prepared for the test.